pressure is what? It is the force which is acting upon a unit area of a surface. Got my point, or should I repeat it?
Ma'am, can you repeat it one more time?
Sure. For example, this is an object, okay, and this object is having like this much of, this is the total surface area of it, okay, and definitely the force will be applied over here, okay, for example, to make it to move downwards, okay. Now, for every unit area, like say this is one unit area, and this is another second unit area, third, and this is fourth. Okay, so for one unit area, we say how much of the force is acting upon. That is called as the pressure. I repeat, pressure is what? It is the force acting on one unit area of a surface. Got my point?
Yes.
Okay, so like if I want to get to know, like this is the complete surface area, okay, this is the total surface area, and I just want to get to know or calculate the force being applied only in this much of area. So in simple words, how would I explain the pressure is that how much force is being applied in a particular area. Okay,
so pressure is basically the force applied for a unit area.
For a unit area, for a given area, okay, for per unit area, we can say that, okay, but not for the whole surface. Got my point?
Yes.
Okay. Do you know what is the formula for the pressure to calculate it? Obviously, from the definition, you could get to know. You can easily calculate it. Derive
force divided by area.
Good. Yes. So the formula for pressure is going to be force, like how much force is acting upon per unit area. So this is going to be the formula for the pressure. And what are the units for the pressure?
Pascal.
Okay. So how would you denote it? Like what is going to be the symbol for the pressure?
PA.
No, not for Pascal. I'm asking about for only pressure. The symbol depicting the pressure quantity.
P.
It's capital P. For F, it is all force. It is always F, and for area, it is always A. Okay. And what are the units for it? For force, it is always Newton. For area, it is always
meter square.
Okay, so 1 Newton meter square forms 1 Pascal. Got my point or not?
Okay, yes, ma'am, got it.
Okay, so international system unit for the pressure parameter is what? It is the Pascal. In short, it is written as this PA, capital P, small a. Got my point?
Yes.
Okay, so next is now like from deriving the units for force and area from the formula, we get that the formula for pressure becomes newtons per meter square. So for 1 Newton per meter square, it becomes 1 Pascal. So you can be asked about like, what do you mean by 1 Pascal? So you would say it is force of 1 Newton acting upon 1 meter square area. Got my point?
Yes.
Okay, good. Okay. Now from this relation, yes.
So like if they ask like what 1 Pascal is, we can even write the formula, right? Like 1 PA equals to Newton m square.
For what they are asking if?
Like if they ask what is 1 Pascal equal to, we can even use like the formula nm
Use
square.
the formula for deriving the answer. You can use the formula for deriving the answer.
Yes.
Okay. So that, but ultimately you have to give the correct statement, the full complete statement that 1 Pascal means a force of 1 Newton acting upon 1 meter square of area.
1 meter. Okay. Yes, ma'am.
Now, obviously, I hope it's very clear from the formula that like it's mentioned that pressure is equals to force upon area. So that means pressure is going to be directly proportional to force and inversely proportional to
Yes, area.
Area. So what does it mean? Tell me.
So force, pressure is proportional to force and inversely proportional to area.
If I ask you
And
that, listen, if I ask you that pressure is directly proportional to force, then what would it mean?
mm,
Directly proportional means that it will directly depend upon that parameter. That means if that means pressure would directly depend upon the force. If force
force
is increasing, the pressure would also increase.
increase.
This is the meaning of directly proportional. If I'm saying
Oh,
that area is inversely proportional, that means it is an upon. Okay, the
okay,
value or the parameter is in denominator, we say. Okay, so in
okay,
inversely proportional, it becomes the opposite. If area is increasing, the pressure would
decrease.
decrease. This is the real meaning of it. You should know,
O-
and this is very much important for higher classes.
Okay,
Like, what does it mean for directly proportional and what does it mean for inversely proportional? This is very important. Okay,
mm,
so now from the formula, we get to know that pressure is inversely proportional to what?
force.
Inversely proportional to what?
Oh, inversely, area.
Area. Okay, so directly proportional to the,
Force. And
okay,
in
so yes,
area
so if force would increase, the pressure would ultimately increase, and if
increase,
area is getting increased, the pressure would
decrease.
decrease, and vice versa. If forces if area is less, then pressure would be
More.
high. Okay,
Yes.
got my
Okay.
point? Okay,
Yes, ma'am.
now there you can be asked about like different types of pressures. This is not a big or very important topic, but only on the basis of the medium through which the pressure is being applied there. On that basis, we divide the pressure. Okay, so we say that there is solid pressure, there is liquid pressure, okay, and then we have the gaseous
Or
pressure.
gaseous.
Okay, so obviously, what would you mean by the solid pressure?
Its particles are packed together.
Pressure is what? How would you define pressure? It is the force acting upon an area, isn't it?
Yes,
So you would directly say that the force that acts upon the solid surfaces, that is what? The solid pressure.
solid pressure.
Okay, and liquid, you know that it can flow in any direction, right? So we
Yes,
say that liquids press in all direction. That means they get pressed, they get pressurized in all the direction. And same goes for what? The air,
and
the gases. Got my point?
yes,
Okay, now next, something very important to know. It is not a big topic, a big point again, but this is something very important. Sometimes it is like small points to be kept in mind so that you could explain all of the tough topics of it. Okay, so it is that, what would you, okay, if I ask you now, what are going to be the factors on which the pressure is going to depend?
factors the pressure is gonna depend on
Yes, obviously it is going to be the force
force. Then
and
the
area.
surface area of
Okay, so these are the two main factors that would affect the pressure directly by increasing or decreasing. So we get to, we can find out what is going to be the value for the pressure from proportionality, isn't it?
yes.
Now you should know another thing about it is, okay, we are done with the pascals, we are done with the area. Okay. Um, okay. So now, like talking about the last part of this topic, like just talking about the introduction to the pressure, then we'll be done with the introduction to this topic. So now from this formula, pressure is equals to force upon area. If it is if I say that it's small area present there and it is larger area available there, okay, so what will be the pressure being applied? If it is very small area, so what is going to be the value for the pressure?
So there will be a larger amount of pressure.
Exactly, good, yes, it will be larger amount of the pressure being applied there. Larger area would
There will be small amount of
exactly. So
pressure.
can you give me two different examples or any one example in comparing it that would prove that yes, both of them are inversely proportional to each other?
Oh, so we can say mm,
Okay, let me give you one
um,
example. For example, a girl is wearing high and very pencil heels, isn't it?
yes,
And when she's walking, because the heel is having very small area, small surface area, right? So more of the pressure would be applied by her feet, isn't it?
yes,
Right?
and
And
less
applying
by.
more pressure, the feet will be working upon, the feet will be applying more pressure. That means the feet have to work more. Okay, so in that case, what would happen? You would feel your feet tired or fatigue
Time.
or restless, isn't it?
Yes.
So same goes for the not same, I would say, but opposite goes for the larger area. So for example, there is a girl who's wearing block heels or flats. Okay, so what would happen? Because now the surface area of the slipper or the footwear would be
More. So
larger. It
larger.
would be more, right? So it will be
Yes.
less pressure being applied by the feet and you'll be feel relaxed.
Yeah. You
So
won't feel any pressure on your legs to like
exactly, it
balance.
won't be like that you or your feet are going to be apply like they would apply more of pressure. No, it is not like that, because now the surface area is more, so less of your feet need to apply the pressure over there and they will be more relaxed. Got my point? I guess
Yes.
there could not be any other or easy most example in this for us
Yes.
being girls. So that's all. Okay.